Welcome to series of conceptual classes on organic chemistry. Today's class is class number 8 and I have chosen the chapter alcohol, phenols and ethers. Out of 3 parts of these chapters, I have taken the small unit ethers. Maximum of the students thinks that ether is a small unit and it is of less important. From my experience of teaching, I think ether is also very important. And here I am going to mention that this year, NEET 2023, a question from ether has been asked. So, before starting ether, let me first tell you what is an ether. Actually, from the structure point of view, if I simply write ether, it is divalent oxygen is there and the 2 valency of oxygen is occupied by 2 R and R dash groups. A bit later I am telling what is R and R dash. That are 2 are maybe alkyl, halide, and 2 are maybe aryl. 1 are maybe alkyl, 1 are maybe aryl, like this. Later on I will explain. So it is, ether is having divalent oxygen where there is 2 lone pairs of electron, and this part of oxygen, first of all you minutely follow, this is ethereal oxygen. To make the ether a very important class or interesting, first of all let me tell some of the uses of ethers. What actually, in which aspect or in which way ether is used. First of all, uses of ether. The vapors of ethers, vapors of some ethers are used as vapors of ethers are used as miticide, fumicide, insecticide. Number 2, from many days earlier, long ago, ether is used as an anesthesia. The anesthetic use of ether is very important in the fact that it doesn't affect heart and lung. But complication is that the recovery of the patient is a bit long. So, for this point of view, nowadays ether is replaced by ethane, halothane, isoflurane, etc. Number 3, ether plus alcohol is a type of petrol, is named as natalite. And next one, ether plus carbon dioxide solid is used as refrigerant, which has the ability to reduce the temperature up to 110 degree centigrade. This is the first part to make you a bit interested towards ether. What actually ether is and how ether is used, what are the ways. And last is, ether is a very good solvent. I will tell you the way, why it is so. These are some important ideas of the uses of ether. Today's scheme is first introduction, second uses, third structure, fourth properties, fifth preparation, sixth reaction. This is the scheme of today's lecture. I will completely follow one by one. Be patient and follow the class from starting to end if you want to be benefited in any type of exam in your life. So, first introduction part and usage is over. Now let me come to the second part, third part, structure. Very important, structure. If you draw the ether, you will find the representation of ether is like this. To look at this structure, you can remind the structure of water and structure of alcohol. So there is similarities among the structures of ether, water and alcohol. So now let me tell some of the properties depending upon the structure of alcohol. It is sp3 hybridized. I don't know, do you have any knowledge how to find out hybridization? It will take time, but in very short I will tell that hybridization, to find there is small trick to find out the hybridization. Say it is also sp3, it is also sp3. I am telling within a short time how you find hybridization. It is a very simple. I think you have not got this one. You take this one hand, that is bond pair. You take this one hand and each pair one hand. But cation is not hand. So you have got 4 hand. So 4 is equal to sp3. 1s, 1, 3 is equal to 4. So its hybridization is 4. But structure or geometrical shape is a bit different due to the presence of 2 lone pairs of electron. You will find this in electron shell valence shell electron pair repulsion theory. Later on I will discuss in the class, next classes in organic chemistry bonding. If you want to find out the hybridization of this one, again if I tell what is the hybridization of this one, you take both this, all these things is one hand and this is just 2 hand. So there is total is 2, 1 and 1, this is 2. This is the shortcut way to find out. Say carbocation 1, 2, 3, am I right? If you ask to find out hybridization, this is 1 hand, this is 2 hand, this is 3 hand, but cation is nothing. So 1, 2, 3, you are getting 3, am I right? It is sp2 hybridization. This is very small trick to find out hybridizations. As a side discussion, side-by discussion, I have shown you a very small trick how to find out hybridization. But my main motto is to explain some of the facts regarding the behavior of ether, which we can draw out of the structure of ether. Out of the structure of ether. So you see in ether there is no CO bond, there is no CHO bond, there is no any other functional group as chlorine, bromine, etc. Due to this fact, ether is less reactive. And it doesn't undergo a reduction reaction very easily, oxidation, etc. So one of the facts is that in other chapter we have come across a lot of reagent, oxidizing agent, reducing agent, and lots of this. But here we will not discuss about this because due to the absence of these functional groups, ether doesn't undergo oxidation or reductions or any type of the other type of reaction. So chiefly because of the presence of this lone pair of electron, ether has got some reactivity. Now you see there is no hydrogen attached with the ether. Due to the absence of that hydrogen, ether with ether, there will not be any association of molecule. So there will not be the association of ether with ether molecule association is lacking, and due to this it has got low boiling point. Whereas in water and alcohol, I have effaced it out. You have seen in both the cases there is hydrogen with this. So hydrogen, due to the presence of hydrogen in alcohol and water, there is intermolecular, water with water, alcohol with alcohol. So there is huge association of molecule, assemblance of molecule, and due to which their boiling point is more. So in comparison to water and alcohol, ether has got less boiling point due to the absence of hydrogen and intramolecular hydrogen bonding. Now, but ether, if you think of ether in this way, and if you think alcohol as this, so you will find there is intermolecular of hydrogen bonding between ether and alcohol. So ether is soluble in alcohol. So we have seen from these two behavior that the maximum reactivity of ether is chiefly based on lone pair of electron. A bit other type of properties are there. I will bit by bit I will going to mention. This is all about structure and property. Now preparation. Preparation part is very important. Always a lot of questions are asked in the exam from this point of view. So please be minutely follow this part. Number one, ether can be prepared from alcohol with concentrated sulfuric. So you know it dehydrated. So with this reagent we can produce ether. First of all, you see this is ethyl hydrogen sulfate. This is ether and this is everybody of knew ethene. So let me tell about the temperature. You please keep it in your mind. this is less than of this temperature, you will get ethyl hydrogen sulfate. So ether can be prepared with the help of concentrated sulfuric acid at this. This is the reactions of alcohol with concentrated sulfuric acid is temperature based. With this, at different temperature we are getting different product. So this is the complexity that it is not easy to get ether because of this temperature. Again, there is another fact. If you take the alcohol is 1 degree, 2 degree, 3 degree, again there will be variation of product. We will discuss in alcohol part, variation of product to be obtained in the reaction. So due to out of these two complexity, we do not readily get ether. So later on, a bit later, I am coming how ether can be prepared safely, and this process is Williamson's ether synthesis, and this is a very important, and each and every competitive exam and NCERT or board exam question are being asked from Williamson's ether synthesis. I am coming later. So now let me take one more example from where we can also find ether. Minutely you try to follow this reaction, and I have some aim to write this reaction out of which we get ether. And how we get ether, you just follow. And what is the main aim why I am using this reaction, I will explain just a bit later. You see, first second, here there is a proton. This breaks into this. Am I right? So this bond withdraws and that attached with this. Bond is withdrawn here, negative sign attached with this. What we get here is CH3, CCH3, CH3, CH double bond, CH2 and 1H, CH3. Bond has been withdrawn, and this is attached. You are getting. So my main focus why I have taken this example here, main focus and why I am showing the mechanism is you can understand yourself if you minutely follow. This is 2 degree carbocation. Maximum of the student doesn't follow this step. Whenever you get any cation, your first and foremost duty is to check whether there is any chance of shift of methyl, that is rearrangement of carbocation. It is very essential one. Before reacting, here your next reaction is ethanol. In alcohol also have already shown there is lone pairs of electron, is negativity is there, and this lone pair of electron negativity will attack in electron deficient center. Electron rich center will get attached with this one. Am I right? So as soon as you get this cation, maximum of the student do what? They make attack of this, but this is wrong. What you do here is you make shift, methyl shift and see whether there is any change in stability of the carbocation already formed. You see it is 2 degree, 3 degree. So on shifting, on rearrangement, if you see the carbocation has transformed from 2 degree to 3 degree, that is less stable to more stable, then your next step is to make reaction with ethyl alcohol or ethanol. So what we do here is CH3, 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 C2, H5, or you see oxygen has got 1 to 3, it is positive. Next step, deprotonation occurs, bond withdraws here, you get the answer CH3, CH3, or C2H5, CH3. You have got ether, no doubt you have got ether. Or it is ether. But earlier, had you been added this ethanol at first 2 degree carbocation, your answer would have been different and it was wrong. So why I have taken this example? Because this time in the NEET 2023, a question was asked like this. You see, if you recall, the question was like this. Just you see, what happens here is, this is plus and minus, this is acid, protonation is there, proton is there, so there is lone pair, so this will get attached with this one, very simple, with H plus, what is the mechanism? CH3, CH3, this CH or H2, this will be instantly plus, and this is 3. And what is the next step? Next step is water is released, loss of water occurs, you are getting CH3, CH3, CH, CH3 plus H. See, it is 2 degree. A bit earlier I have shown you that if there is 2 degree carbocation, your instant thinking should be that are there any chances of transformation of 2 degree to 3 degree. So if carbocation changes, if there is chances of changes of carbocation to become 2 degree to 3 degree, the stability will acquired in this process. So the next reaction will occur through 3 degree. So instantly student did what? They attacked this. Whenever they get 2 degree carbocation minus that negative part, they attach negative part here, answer is wrong. They will give big 0. They will get big 0. Now what's happened here? You see there is shift of hydride. So what you get here is CH3, CH3 plus CH2, CH3. Is it not 3 degree? Then you add bromine, CH3, CH3, Br, CH2, CH3. Maximum of the student added bromine here. Answer, they got the answer, wrong answer. So rearrangement actually, shift carbocation 1 degree, 2 degree, 3 degree. Carbocation shifted by shift of what are the things? One is hydride shift, SHI shift, other is methyl shift, other is phenyl shift, other is ring expansion. Rearrangement occurs through ring expansion. I will tell it later. So these are the things which may be shifted to get stabler carbocation before attacking the carbocation by nucleophile. So these are the some process. This is the one process through which we can get ether from alcohol and ethene. Am I right? So our next one is Williamson and very famous Williamson's ether synthesis. Ether synthesis. Williamson's ether synthesis. Williamson was an American chemist who made a process, and with the help of which we can very easily get any type of alcohol. Sorry, ethers. Ethers are of, what are the types? Ethers are symmetrically. Number 2, classes. Unsymmetric. Number 3, aliphatic. Number 4, aromatic. Number 5, cyclic. Cyclic ether. Am I right? Symmetric means divalent, on both sides of divalent you will get same key. This is symmetric. Same group. Unsymmetric means if one group is ethyl, other group is same. For example, I have taken. Aliphatic means these are aliphatic. Aromatic, if one part is aromatic, other part is alkyl, or both parties benzene ring, aliphatic as aromatic. And cyclic. Before coming to Williamson's, I have left simple one point, cyclic. Very often question comes from cyclic in entrance and also in the class board or NCERT. So please let me explain a bit on cyclic ether. This is classification. This is classification. Am I right? So these are very simple, nothing to explain. So cyclic ether, what is example? Tetrahydrofuran is an example, or 1,4-dioxane, etc. A lot of things are there in cyclic. But my main motto today, I want to explain some of the very important things. Very often you will find in the book. One is crown ether. Crown ether. So today I will take 10 minutes, not more than 10 minutes. Crown ether. Crown ether. What is actually crown ether? Crown. So the meaning of crown, everybody, if you know, which is where up on the head, crown. And what is crown ether? Crown ether actually polyethers. These are polyethers, and they surrounds specific polyethers. Polyethers surrounds specific cations with full or more number of oxygen atom besides CH2 or part, means which appears like crown. What does mean? This is polyethers. There are a lot of ether, and out of polyethers, among polyethers, you will get some oxygen included in the cyclic process. And in besides oxygen, again on both sides of oxygen you will get CH2 group. Ethylene oxide part is there. When I will give you example, you will understand what is crown ether. It is not important for board exam in Assam or others, and for in NCERT or in entrance exam it is very important. So I am giving you some examples. You please keep it in your mind. And why I am explaining crown ethers? These are a lot of implications in organic chemistry. I will explain it. Though it is a bit higher in level. 12 crown for it is lithium cyanide. I will explain. And number 2 is 15 crown 5 This is sodium hydroxide complex. This is 18 crown. This is potassium permanganate complex. That is crown 7. This is with cesium. Like this, you will find up to 81 crown 27 experimentally found. That last number was 81 crown 27 ethers. So let me explain a bit. What is first number 12 mean? What does first number 12 mean? Let me draw 1 2 3 4 1 2 3 4 like this. This is CH2 CH2O, CH2 CH2O, CH2 CH2O. You count the ring. 1 2 3 4, 3 4 is 12. So this is nothing but number of atoms. 12 is nothing but number of atoms. You assume 1 2 3 4 5 6 7 8 9 10 11 12. This is number of atoms, total number of atoms in the cyclic structures, ethers. And what is 4? 4 designate number of oxygen. Am I right? And this makes a complex with preferably maybe others, but preferably lithium is there. Lithium ion is there. Am I right? And this is hydrophilic part, and out of this the anionic part get attached in this way. Am I right? So in this way you can draw 18 crown, you can draw 21 crown with sodium metal tapped inside, with potassium metal tapped inside. I am not drawing each and every one, I have shown one thing. So what is the implication of these things? What is hydrophilic? Hydrophilic part is this, and this is hydrophobic. The implication is that it is an inorganic salt, and that inorganic salt is not soluble in non-polar solvent like alcohol, benzene or organic solvent. Am I right? So what if we want to make some reaction of this, want to dissolve this salt in non-polar solvent like benzene? Okay, so we have to use this 12 crown ether. So this crown ether easily dissolves the benzene. If it is solvent benzene, benzene will dissolve here. So let us, so what will happen? That is, if it is not in non-polar solvent, so lithium cyanide in polar solvent like water, what's happened? Cyanide is solvated, negative ion is solvated by cations. But here cation in non-polar solvent, cation is in complex, it is trapped inside. So negative part left bare alone, and due to presence of this alone, because anion is not solvated by cation in non-polar solvent, so anion part is left bare, and this will now act as a nucleophile vigorously in non-polar solvent. Let us take an example of 18 crown 27 was potassium was there. Am I right? So potassium in this. So potassium is trapped inside and outside is KMnO4. if you now use benzene, what is the color of potassium? It is pink color. So the color of the reaction will be purple. Purple means it has undergone reaction. Now how does it undergo reaction? Because here, like Cl, MnO4 is there alone in the non-polar solvent in benzene, and benzene is dissolved in the complex of K inside, and 21 is the structure of atoms, and 7 is the number of oxygen. Am I right? So this bare KMnO4 will oxidize the benzene ring, and the color of the solution changes purple. That means vigorously reacts KMnO4. Whereas that KMnO4 singly in other solvent, not in non-polar solvent. That is, you think KMnO4 simply you add benzene, no reaction. But if you now use 21 crown 7, sorry, I am sorry, 18 crown 6, not 7. I am sorry, extremely sorry. 18 crown 6, KMnO4, K is stuck inside and MnO4 is there, and this MnO4 will vigorously oxidize benzene, and the color of the solution will turns into purple from pink. But in around KMnO4 and benzene does not react. But mind that if it is toluene, that KMnO4 will oxidize CH3 into COOH, reaction will occur. But benzene will not. This is the application. So inorganic salt which doesn't dissolve in non-polar solvent will dissolve if you use the crown ether, and reaction will occur vigorously due to trapping of cation inside it and due to free nucleophile outside. This is one. Number 2 application is it is use phase transfer catalysis reaction. Number 2, it is used in esterification. It is used in saponification. It may be used in preparation of carbene. This is extra information I have seen. Those who are interested, they can keep it in your mind. Otherwise, for normal students, those who do not have huge course in their textbook or curriculum, they didn't go this topic, crown ether. So I have got a time that is type was a cyclic ethers. That's why I have mentioned anything. So I was talking of Williamson's. Very important, mind that Williamson's ether synthesis. Very famous, very important. And why it is important? Because out of this process we can prepare each and every type of ether. Maybe simple ether, maybe branched ether. What type of ether you want, you can prepare with the help of this one. But minutely you follow what I say, then you can answer, otherwise you can't answer. If you simply go through the notes of the teacher and what is the process they have given, you use this and this and this and this. No. You try to know the inner facts so that you can answer the each and every questions. Main fact is Williamson synthesis. Williamson has taken, this is the main things, just you follow. Williamson has taken two things in consideration, and these two things are very important. What are these two things? Alkoxide. Mind that what is alkoxide? Alkoxide means alcohol. What is alcohol? Anything. You write this and make to react with sodium or sodium hydroxide, you will get what? CH3ONA. Am I right? So it is alkoxide, sodium methoxide, alkoxide, ROH, sodium, RO. It is replaced here. Am I right? Na means this is alkoxide. You Forget about Na plus. We'll talk of Ro negative. Methyl, ethyl, whatever is alkyl part. Alkoxide. Alkoxide. And this is what? This is alkyl halide. The main fact, the backbone of the reaction is alkoxide reacts with this and it goes out. That is introduction. Ro is introduced here. Ro is attached with this R. So it is Rdest. Ro is attached with Rdest and Rx is going out. So what you get here is Ro means arrow means Rdest and out. So what the actual thing is that it is SN2. Keep it in your mind. SN2 mechanism. Nucleophilic substitution by molecular SN2. Number 2. Stick to this point. If you want to Williams answer, if you want to answer each and every question in entrance, whatever entrance is this. First one is SN2. Mechanism is SN2. One step reaction, transition state is there. It is SN2. Two step reaction, carbocation is there. It is SN1. Very simple way. There are a lot of things. In decimalization is there in SN1. Inversion is there SN2. And lots of things. I will not talk about this thing because you have got these things in first year. Number 2 is alkyl halide. Alkyl halide must be 1 degree to get maximum yield of ether. We will stick to this one. So let us take an example. Say this is we are reacting with sodium hydroxide or N. What we get is here. This is Na and we take now alkyl halide CH3CH2. Say Br. What happens here is this react with this one and this goes out. So this part get attached to this CH3CH2, or you can simply write CH3O CH2CH3. Am I right? Sodium is there, sodium will react with N, sodium NaBr. I will not write this in. My main focus is on this. This is S1 reaction. Am I right? So if you think it is alcohols, sorry, if it is phenol, what happens with this one? So you take sodium hydroxide, am I right? So what phenol will react? How phenol will react? This will ONA, sodium phenoxide, am I right? Sodium phenoxide, you give and alkyl halide. What happens? This is a SN2 mechanism, negative to this ferro, it will attack as a nucleophile and this will goes out. What we get here is O will be there and attached to this one and this will go out. Am I right? We have got these things. And the famous name is anisole. Each and everyone know this is anisole. Methyl, methoxy, phenyl ether. Next name is acetophenone, and lots of name. It has got a lots of name. It is very important. Every later will come upon. I will discuss it in details in next part. So we are talking about what? We are talking about preparation. Very important part, preparation. So we have prepared aromatic as well as aliphatic cylinder. The mechanism is SN2, one step reaction, and alkyl halide is 1 degree. Wherever we have taken this alkyl halide is 1 degree alkyl halide. Earlier case 1 degree alkyl halide. Now let us see. If you take alkyl halide, just a minute. Yes, alkyl halide. if you do not take alkyl halide as 1 degree, what happens? Let's see. And this is the question asked in the exam. What's happened? Let us take. Alkyl halide is not 1 degree. If alkyl halide is 2 degree, it is a bit different. You will get mixed type of ether and elimination is there. Mind that if alkyl halide is not 1 degree, if it is 2 degree, or if it is 2 degree, you will get alkene and ethers mix in, but if it is 3 degree, you will get maximum alkene. Mind that we are discussing about ether, but we are getting alkene. If we make mistake in choosing alkyl halide, 3 degree in place of 1 degree. Now what's happened? Let us take 3 degree alkyl halide. Am I right? 3 degree alkyl halide. So it is 3 degree alkyl halide. Tertiary. 3 degree alkyl halide. CH3, CH3, CH3 Br. So what was the rule? Alkyl halide and alkoxide. Am I right? So let us the alkoxide be C2H5, and alcohol is replaced, H is replaced by Na. Alkoxide is what? In alcohol, just you replace H by Na. This is alkoxide. Am I right? So I have taken alkoxide. Let's see what happens in this reaction. Do you get an ether, or do you get, or we get alkene? What's happened? This is this part. You forget about this. Forget about this. This part is base as well as nucleophile. A base is nucleophile. A nucleophile is base. Now question: how does base react? How does nucleophile react? This is a bit high thing. I will take one class, nucleophilicity versus basicity. In this chapter I will explain. Today, in short, I am telling, if there is base, the reaction will be reversible. The main function of base is just to extract hydrogen from the reactant. It will take out one hydrogen from the reactant. This is the function of the base, and it will be reversible. And what is the function of nucleophile? The function of nucleophile is that it will get attached to the carbocation. This is the basic difference. But a base is a nucleophile, a nucleophile is a base. Now when a base will act as base, and when it will, same base will act as nucleophile, that depends upon the demand of the reaction solvent, sterical hindrance or bulky groups, and lots of things are there. Nucleophysics, there are lots of factors. Here in the special case, this is a strong base, and it will abstract one hydrogen from this. It will abstract, it will be ethanol. Am I right? And this bond will be inclined here, and this will be released out. This is E2 reaction. What we get is, minutely follow this reaction. This is very important. CH3, CH2. If you ask me why it doesn't attach to this one, later class, next, nucleophilicity versus basicity, I will explain. It is base, it is nucleophile. Here it is acting as a base. Why not nucleophile? Next. So, our main intention, Williamson's main intention was to get ether, but in place we have got eliminated product is alkene. Where was our fault? Our fault is in choosing the alkyl halide 3 degree in place of 1 degree. So I have shown you, if you use 3 degree alkyl halide in place of 1 degree, we are not getting ether at all. We are getting alkane as a measure. This is the reason our choice should be alkyl halide 1 degree. Mechanism should be SN2. Now, you may say that if alkyl halide is 1 degree, so we will always get a linear 1 degree means this. This is alkoxide, am I right? And this is um, um, uh, alkyl halide. Am I right? So always when this will attack upon this one, this will go away. Always a linear type of ether. You are getting a linear. So in your mind, an instantly a question may arise that will you not get a branch type of ether? Because in the very beginning, we deeply applauded that Williamson synthesis is the best process with the help of which we can prepare any type of ether. So we are here getting only linear type of ether. So how can we get a branch type of ether? Because if you want to get branch type of ether, we tried with a branched means 3D alkyl halide to get branched ether, but in this atom we failed. We have sent in place of ether, we have got what? Ethene, alkene. Am I right? So let us see what can we do, because Williamson is very talented one. He did what? He told that alkyl halide should be must be 1 degree, and he was silent about other things now. But what we say that if you take our alkoxide part, say this is 3 alcohol. This is 3 alcohol. Am I right? 3 alcohol. Alkoxide. This is R. Alkoxide part. We have replaced H by N. So our alkoxide. First I told you in this way. Am I right? This is alkoxide and this is alkyl halide. I told you this will react in this way. Alkoxide. We have taken branching. We have taken alkoxide, a branching alkoxide. What we want to do here is say this. Am I right? Instantly, what will happen? It will react in this way. So amazing way. We will get what? Here is very interesting. You just follow. You are interestingly get this. Let us see whether we have followed the two signal. If you cross this signal, we will fall in the ditch. Now let us see, have you followed? Yes. We have taken alkyl halide 1 degree. No doubt we have taken alkyl 1 degree. We have made change on the alkoxide. Let us see the second part. Is it SN2? Yes, it is one step reaction. It is SN2 mechanism. We have divided by the 2 points of Williamson's prediction. So it is a branched. So its name is 1, 2, 3. Its name is 2-ethoxy, 2-ethoxy, 2-methyl, 2-ethoxy, 2-methyl propane. Tarbetoxy, methyl ether. Another name, common. Tarbetoxy, methyl ether. TBME, common name. Tarbetoxy, methyl. Am I right? 2-ethoxy, 2-methyl ether. And mind that this is a tremendously important compound. We'll later on, when we will discuss about the reaction, and this is one of the important questions in each and every high JEE, NWT or state or NCRT, each and every time a question comes from this point. Minutely follow this one. This is very important. We are shortly coming on this one. So this is all about Williamson's ether synthesis. A lot of things are there. I am not going in details because the class will be too much long. To make the class easy, I am coming to the next part of the today's scheme. Today's scheme of next part. What is the next part? Reaction. And this is the last part. And you minutely follow, you will find interest, and you will find the organic chemistry really is in your hand. Reaction. Let's see what happens. At the very beginning, reaction involving, I have already mentioned, ethereal Ether, that is the reason at the very beginning I told you know some of the facts about ether. So first type of, no I will get this. First type of the reactions will be reactions involving ethyl oxygen. Second type of the reaction is what? Cleavage. Cleavage of, say, this is ether, am I right? Chain will go on like this. Breaking, cleavage of CO bond, either here or here, I don't know. Cleavage of CO bond. Main point is cleavage of CO bond. Mind it. You minutely follow this, reaction will be in your hand. Surely you can understand the reaction. Number 3, reaction involving alkyl part. Reactions involving alkyl part, involving this part, not alkyl exactly. If it is CH2, if it is CH3, CH2 or CH3, reaction will occur here. Okay. Reaction involving this, and last one is electrophilic substitution reaction. I have a bit earlier I have told you anisole, acetophenol. Am I right? This will come in it here. So let us see what is C2H5. First one. I am talking about first. Ethereal oxygen. Part 7 here. So say what is the answer? Very simple. This is not tough. You know this is lone pair of electron, always this protonation occurs. HCl will give you proton. So protonation occurs C2H5, all thing true, or here is in this, and this is going to be plus, and this part Cl will be attached to this diethyl oxonium chloride. If you give sulfuric acid, so H2SO4, H will be like this, and here HSO4, diethyl oxonium hydrogen sulfate. If it is H2SO4, H is here, HSO4 is there, hydrogen sulfate, diethyl oxonium hydrogen sulfate. This is all about reaction, but this is not much important. We are now talking about this tremendously important. For exam point of view, any type of exam, maybe entrance, maybe your class exam, maybe board exam, maybe NCERT exam. Now see what we can do with this. This is less reactive because it doesn't undergo oxidation, doesn't undergo reduction, it doesn't undergo any other types of reactions. It's in reactions involved with lone pair of electron. In maximum cases, we have told you earlier. Am I right? Now cleavage means you are breaking this bond. Am I right? You are breaking this bond. So this bond actually breaks in presence of hydroic acid, iodic acid in excess when you get the breaking of bonds occurs. Am I right? So first of all, we'll deal with breaking of bonds with HI, hydroiodic acid. Say first one is, you might follow, this is very important. You don't go blindly to add up H and I in any place. Am I right? This is plus, this is minus. Wherever you add H and O, once you are getting this, other type you are getting CH3OH, one H is here, one I is here, H is there. You can. You are getting one is methane. If you break the bond here, this is negative part, this is positive part. Negative part will get attached with this one. You are getting CH3. Am I right? You break the bond here, this part will be negative OH, negative, along with negative you are getting positive CH3OH, and positive you are getting negative, we are getting positive, this part is this. So if you take this as an example, what will happen? I am writing the answer, but you will be confused a bit later on. You will be confused. You will be confused. I am writing CH3I plus CH3 CH2 OH. If you make it 2 degree, CH3 CH2 CH3 again like this. If you add up in this way, okay, you yourself can do. Okay, if you make these reactions in this way, you give HI. Am I right? So the answer will be CH3 CH3 OH plus CH3, right? So from this reaction, what you can infer is that the negative part of acid is get attached with that carbon on both sides of oxygen, which is less substituted or less crowded, less substituted or less crowded. I am telling why. This is the point. You see, in this case nothing. You add here CH3 or OH here, both the weight is correct. But here the things come. This is less substituted or less crowded, hence negative part attached to this. This is more substituted, more crowded, OH, H is attaching here. This is more substituted, more crowded, so your H part is coming here and I part is coming here, less substituted. This is the point, am I right? This is the rule we have seen from here. But mind that simple rule doesn't come in the exam. You will get some exception of the fact. And what is this exception? And these exceptions are the very important for any entrance or class or NCERT exam. Now see that our generalization is wrong. What we do here to get this one, let us take one example of this one. See a bit mechanism I am showing you. Is in each and every step I say mechanism. You don't get afraid of the mechanism, but it is very interesting and very important. In the reaction mechanisms where there is an acid, there is H positive is there and H proton will get attached with this one. You will get protonation step first. Am I right? You will get protonation step first. Whenever you get proton, you are getting a positive part. Am I right? So what's happened here is, what's happened when you get this one? When you get this one, next part is what's happened. Iodine is a nucleophile. It will attack here. You must have some concept on SN2 and SN1 again. SN2 is a single step reactions where it will get attached and another will get reduced. There will be transition state. Now what's happened? That nucleophile, what is the condition of this person? This is very danger person. Okay, this always attack the place where the path is free. If there is any crowd, bulkiness, it refuses to go due to security concern. Am I right? So if it is crowded, this part is crowded, it will deny to enter or attack in this part. This is free, less substituted, less crowded. It will like or intend to attack from this side. Am I right? So what's happened at transition state? I am not showing you. I am not making it clumsy. I C this and next part CH3I will break up and this OH will break up here. I am not showing you. So it will attack this and it will break here. You are getting CH3I and next CH3. This bond will be done here. Am I right? It is transition state. I am not showing you this in this way. Just will attack here and this. We are talking about CO breaking bond, cleavaging here. Whenever nucleophile attack, it will get attached. A bit earlier I told when nucleophile attacks, it get attached. When base attacks, it extract hydrogen. Two things. Am I right? So the VIP person, VIP thing I naught or nucleophile, that it attacks the species on the less crowded part or less substituted part. That's why CH3 for general rule I part always attached to the less number of carbon atom, less crowded one, less substituted one. Am I right? But question comes in exam. The question is what? Question is what? CH3, 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 or CH3. A bit earlier I had told you, or 2-methoxy-2-methyl methylpropane. Now what's happened? You see HI. What's happened here is answer is reversed. As per rule, that I should be attached with less substituted one, but this part is wrong. Now what's happened here is that at the very beginning the protonation occurs here, am I right? H plus will attach here. So what's happened here is just you follow a bit regarding the mechanism. Negative part. What is the mechanism? Mechanism will be this negative part attack this lone pair will give it. This is beggar. Nothing is there. Am I right? They are rich in electron. So what's happened? That H will get attached with this one, and there will be cleavage of the bond. This is 1 to 3 bond. This is plus. The bond will backs like this. It will become CH3C, CH3. CH3 plus CH3OH. Am I right? So what you get here is a carbocation of the type 3 degree. Now protonation next is attack of nucleophile I negative. Instantly will attack here. Now earlier what we told, that nucleophile is a very sensitive person, very famous person. It likes to attack the substrate on that part of substrate which is less crowded or less saturated. But here we see the matter is quite reversed. Why? Because of the chances of formation of carbocation of the type 3 degree. When 3 degree carbocation is there, there is nucleophilic attack, and this is SN1 mechanism, because there is not transition state, one enters, other out. No, it is two-step reaction. First carbocation formation, then attack of the nucleophile. Due to the SN1 mechanism, and earlier was SN2, less substituted product, I was attached. Oh, each and every reaction was of the type SN2, but here in this special case we have got the reverse of this answer. Is question very often asked on this one. If you don't have the knowledge on SN1, SN2, you will not do is by trying it over and over again, or learning it by heart, or seeing the notes of your teacher and this and that. You go to private tuition and like this. You please don't confine your knowledge upon the notes. You go through the books and try to understand yourself. Am I right? Next one is this is the type of the reaction where the answer is reversed. Now what's happened? Yes, another part you minutely follow in entrance exam. What's happened? There is heat is given. If this is given, your answer is two part. One is alcohol, it is fixed. One is alcohol and one is alkyl halide. And in option 1, option 2, option 3, option 4, they will given one is alcohol, other is alkyl halide, one is methyl, or other is 1, 2, 3, 2 methyl, 2 iodopropane, like this they will say. But mind that if there is heat is there, in a book it is not given, heat is there, then this alcohol again will react with HI, releasing out water to give you CH3I. So in the reaction mixture, you are getting both I, one 3 degree I halide, other is 1 degree alkyl halide. If it is given one alcohol, one alkyl halide, answer wrong. One CH3I, CH3C, CH3I, this answer is correct. Mindfully follow this one. So one thing I have left, I think, that is, I told you, if it is ether, very simple one, no complexity is there, what will be answer? Just you write the answer is, this is the answer. We have learnt it earlier. But if it is excess, question comes in your board and NCERT exam. What's happened? If it is excess, then this methanol again reacts with HI. So what we get here is this. Next, I am coming to this one again. I am coming to this one. So it is a bit hard. You just try to keep it in your mind. If it is CH3 or CH3 2-methoxy 2-methyl propane, and if it is concentrated sulfuric acid, what will happen? Again you see what's happened here is it is acid. Am I right? Acid means proton. It will release proton 1 or proton 2 proton. It will give H plus, and there is huge electron density. There will be protonation. When acid is there, there will be protonation. Am I right? So what we get here is this. Am I right? You are getting here this, and this release out as earlier. We have shown you a bit earlier. CH3, CH3OH is here. Am I right? So what you get here is this is carbocation, but here is no nucleophile to attack here. Like it will released, and this will be inclined here. So you are getting the answer elimination. Am I right? Try to keep it in your mind. It is a bit hard. So our next part I am making a bit fast. Just follow me. Next part. This is anisole. What we will do here, again there is a question of thinking. As per rule, I should attack the less substituted part and other part in other things. Let us see whether this answer is correct or not. Now you think one thing, there is carbon. Am I right? There is carbon. So there is two type of bond. This is carbon oxygen, and another type of bond is oxygen carbon. Two type of bond. Let us see which type of bond is weaker, because you are trying to break bond. Either breaking will be minor ke follow. You please follow the class a bit. Attention, a huge attention is needed. Your breaking will be either in this part or in this part. Now you yourself is to decide in which way the breaking will occur, and what is the logic behind the breaking, what is the reason, what is the chemistry lying behind it. See, phenyl group is a electroneutral group. Phenyl, that benzene itself is now, it is along with this a lot of things is attached. It is a phenyl group. Phenyl group is electron withdrawing group is withdraws electron, thereby OCH3, that green part, OCH3 part is weaker due to the minus I effect of phenyl groups. So first reason, the bond will break in OC position. The bond will break in OC, not O and carbon of benzene. No, it will not here. And this happens when it is protonated. Am I right? When you are protonating this occurs, and this is acting as electrophilic. Electron withdrawing parts, phenyl groups and withdraws electron when protonation occurs. Am I right? Now, another point is that if you want to break here, if you throw out all the logic of weakness of this OC bond to break here, if you tell that I will break here, you can't break it, because you can't break it. If you want to break anything from here, you are trying to break this part, and another is substituting, because all type of reaction is SN2. Am I right? SN2 mechanism, nucleophilic substitution there. In aromatic compound, substitution reaction does not occur instantly or easily. Under drastic condition, you can break benzene and other compound, otherwise you can't. So you never think of breaking the bond here. Never think. If you don't know any reason, don't touch here. No reason. You don't try to take this one. So we will break this bond. You will break this bond where? We will break this bond where? We will break this bond we will break this bond here due to the fact when after protonation of this withdraws electron, OC bond will be weaker. Or on the other hand, OC in benzene rings they are never substituted because aromatic compound doesn't undergo substitution because of partial double character of this bond. Am I right? So what we get here is OH plus CH3I. This is the answer. Without any reason, you don't give any answer. Now, very interesting part. I am showing you very interesting part. I minutely follow this part. This is the question asked this year NEET 2023. Maximum of you get the wrong answer. Mind that, what were the two options of breaking a bond? I told you, don't break this bond in this position because substitution reactions in aromatic compound is not easy under the strict condition. This bond can be broken. So only way left out is breaking bond here. Am I right? So if you break this bond here, this is negative and this is positive part. Am I right? So negative part you add what? Positive part. So what we get here is this. What we get here is this. Am I right? This is the answer. Maximum of you got either negative or 0. Am I right? So this is the question asked this year 2020 in the NEET exam. Mind that you get you be always prepared to get answer from reaction and emulsion synthesis. These are the two important part of the ether, and it is very interesting chapter. In the volume it is a very short, very concise, and no maximum reagents are limited to 2 or 3 reagents have been used, but lots of things have to be known. And if I make the speed of the my tempo of saves time. So next one and last one is electrophilic substitution reaction. So please bear with me. I am making a bit haste. You see OCH3. This is this. Am I right? So what's happened here is I have got it in first layer. I think this bond withdraws, and the reason why I am explaining this is you will understand yourself very easily. Next step, this will come here, this will go there, this will resonance will occur. Am I right? You all know this. I think everyone knows and understands the fact I am explaining. I did earlier this fast only to make the class short. Please bear with me for your understanding. I am doing the class a bit fast. Phenitol, methoxyphenyl methyl, or acetophenone. The same. What is the target of doing this one? In first year you have done it, but some of you may not know what's happened. It is ortho and para-directing group. Why? Because in ortho position and in para position there is negative sign, and negative sign is the electron density is more in ortho and para position. We are dealing about electrophile. Electrophile is positive in nature, so electrophile enter here with substitution of hydrogen. That substitution electrophilic substitution reaction will occur. So any soul will show electrophilic substitution reaction. One by one. This is very simple and this is very easy. Nothing to learn. You yourself just to follow my class, you can understand. Nothing to learn, nothing to practice. You see, this is anisole. This is anisole. This is anisole. If you want to react to, you want to bromination, halogenation, in carbon disulfide. So this is ortho and para electron D is here, there will be Br plus electrophile is there. So what will happen here? In one time bromine will be here and other time bromine will be in para position. It is major, always para is major. Number 2, again anisole, what will happen? Friedel-Crafts alkylation. Friedel-Crafts alkylation. Friedel-Crafts alkylation. Am I right? It is anisole. You just do one thing. CH3Cl, anhydride aluminium chloride, LCl2 will take one chlorine, you will get CH3 plus electrophile. Again ortho and para directing. Anisole OCH3. This is CH3 and here you are getting OCH3 and para. Again this para is the major. Next one is acylation. I am making a bit fast, taking the time as the factor. So this is CH3CO. Again anhydride, it will take one chloride and COCl will be positive electrophile. So what we will do here is COCH3 in ortho position and here OCH3 in para position. This is again major product. If you want to make nitration reaction, you get nitrogen nitrating mixture. So you are getting 2 part, one nitro is here, ortho and other part. You are getting OCH3 and NO2. Sulforation, sulfuric acid, this is concentrated sulfuric acid. One thing I have left out, and this may be the last of my class. One reactions I have missed out, the reaction involving with this. And just to follow up within minutes, I am going to finish this one. Reaction involving with this. See what's happened here. CH3, oh, this is CH3 plus oxygen, long time. If you keep ether open for long time, what's happened? You see, the reaction is very simple. CHOOH and OCH3 and other one is CH3 CH2OO CH3. I can keep both the same or may not keep both the same. This is a hydro peroxide compound, that is diethyl. You keep it diethyl. C2H5, keep it C2H5, make it C2H5. Am I right? You make it C2H5 diethyl. It is peroxide of diethyl ether. Why I am taking? You see, reaction involved with this one. Am I right? So reaction is involving either of this or of this. Same thing. One hydrogen is replaced. One hydrogen is replaced by OO, and that hydrogen goes here. It is not mechanical. This is the way of shortcut I am taking. So that is hydroperoxide. And this is peroxide of diethyl ether. Now these two bonds are very dangerous. Upon heating, they will explode. So that's why ether is not dry distilled. A question very often comes. It is not evaporated at dryness. EVA. It is not, ether is not EVA, evaporated at dryness. Very important, at dryness, because when least amount of ether is left in the beaker, when evaporation process is on, then with the presence of oxygen, it makes hydroperoxide or peroxide of diethyl ether, and on heating it explodes. It will create danger. This is the reason. This is the end of my class. Thank you for you all to be in the class from first to last. Hope you have enjoyed the class at the best.